Hello, today we're going to be doing path crossing, which is LeetCode problem 1496. This problem states, given a string path where path I equals character N, character S, character E, or character W, each representing moving one unit north, south, east, or west, respectively. You start at the origin 0, 0 on a 2D plane and walk the path specified by path. Return true if the path crosses itself at any point. That is, if at any time you are at a location you have previously visited, return false otherwise. So in example 1, we see start out, go north, then east, then south. So this never goes back to the origin. So we return false. In example 2, we see goes north, east, south, west, west. So it does cross the path of origin. And so we return true. So the way we're going to code this is pretty straightforward. We'll have x equal to 0, which corresponds to the x coordinate. And y, we'll set that also equal to 0. I realize you can put these on the same line, but sometimes I just do this for readability. Next, we're going to set a hash set. And we use hash set because it is an unordered list. We don't need to waste time with use more memory to put things in order. We'll call that visited when it goes back to the origin, and we need to instantiate it. Okay, so the problem states that we start at position 0, 0. So we will start there. That's really all the setup that we need. So now we're just going to loop through the path. So we'll do each character, call that the direction we're going, in path. And in order to parse through that, we need to convert that to a char character. Okay. So if, this is just a lot of brute force coding at this point. So if direction equals capital E, well then we've moved to the east. So that moves position X to the right. Else, if direction equals, let's just do west. So now X moves to the left. So we're going to do X minus minus. Else, if direction, you guessed it, equals, well, let's do north. Why not? So now we're going to remove. Now we're going to move position Y. Moves up, so we increase that value. Else, if our last direction south, then we're going to do Y minus minus because it's moving down. All right. So this takes care of moving X and Y. So what we need to do now with that, we'll define a string here. And because I love to spell out variable names, I'm going to call it current position instead of like cur pos or whatever the standard convention is. So basically we're just going to build that string. So we're going to do X plus, and we're going to need the comma, and then we need to add the Y. Then we need to check that. So if visited, what am I doing? Contains current position. Well, then we know that it's passed through back to the point of origin. So we can just return true. If it doesn't find it, which it won't the first time through because visited only has 0, 0 on it. So we're just going to add that. I'm going to add the current position that we just built. So that will add, down here, this will add the position to the visited hash set. And we'll just keep looping through until we either find it or we don't. So if we don't find it, then we've got to return false. And there you have it. Okay, the one mistake I made is not making that T lowercase. I'm so used to C# that I sometimes get those two confused. Okay, so our test case is down here. North, east, south never returns back to the origin, but in case 2, northeast, south, west, west, we do go back to the origin, so it returns true. All right, let's debug this quick. So we have visited, which we've set to 0, 0, x 0, y 0, and the path is NES. Nintendo Entertainment System. All right. So first direction is going to be north. North, so y plus plus. We set current position equal to, in this case, 0, 1. Does it contain it? No. Oops. So we're going to add it to the list. Now you can see on the left there, visited is now 0, 0 and 0, 1. So now we're doing it again for the E, x plus plus. So we're going to build the position, which is going to be 1, 1. And visited hash set does not contain that, so we need to add it. And then finally we're going to do the S. Direction is S. So we decrease y. So now current position equals 1, 0. And the visited hash set does not contain that either. So we're going to add it to the list, but it doesn't matter because we've exhausted the path length. And so it just returns false. It was accepted. So the time complexity is O of n. The only way it's going to get bigger is if we increase the input, the path input with multiple directions. Same for space complexity. We'll increase the space we need with multiple, or with addition to the path. And that's it. Hope you learned something. Let me know you have questions. Thanks so much for watching, and we'll see you next time.